Let us integrate the integral of dx all over x times the square root of x squared plus 4. The integrand shows a sum of two squares in the denominator, but it cannot be readily integrated as is. So we have to use a suggested substitution for a sum of two squares where x is equal to a tangent theta. U squared is equal to x squared in the integrand, so therefore u is equal to x. A squared is equal to 4, so a is equal to 2. We will use the substitution x is equal to 2 tangent theta. Taking dx, it gives us 2 secant squared theta d theta. If we substitute the value, it gives us the integral of 2 secant squared theta d theta all over 2 tangent theta times the square root of 4 tangent squared theta plus 4. Simplifying further, we get here the integral of 2 secant squared theta d theta all over 2 tangent theta times the square root of 4 tangent squared theta plus 1. From here, if we apply our trigonometric identities and simplify it further, we get a simplified form of the integral, which is 1/2 times the integral of cosecant theta d theta. This is integrable and we have a formula for this. So this becomes 1/2 times the ln of the quantity cosecant theta minus cotangent theta plus c. Since we made a substitution where x is equal to 2 tangent theta, we can say that tangent theta is equal to x over 2, wherein the angle theta is equal to the arctangent of x over 2. Since tangent theta is a ratio of the opposite side over the adjacent side in a right triangle, if we construct the triangle, we have to place x as the opposite side and 2 will be the adjacent side. The hypotenuse can be solved by the Pythagorean theorem, which gives the square root of x squared plus 4. From the right triangle, we can get the value of cosecant theta, which is a ratio of the hypotenuse divided by the opposite side. And that gives the square root of x squared plus 4 over x. It follows that we could take the cotangent of the angle theta, which is a ratio of the adjacent side over the opposite side, which is 2 over x. Now, we are ready to substitute the value of cosecant theta and cotangent theta from our temporary answer in terms of the angle theta. So, substituting the values, we get 1/2 ln of the quantity square root of x squared plus 4 over x minus 2 over x plus c. Simplifying, we take 1/2 times the ln of the quantity square root of x squared plus 4 minus 2 over x plus c. If we will evaluate the integral of dx over x cubed times the square root of x squared minus 9, you notice that the integrand has a difference of 2 squares in the denominator. but it is in the form where it is a variable minus a constant. Using the basic formulas of integration, we cannot integrate this term yet. So we will try to use trigonometric substitution for a variable minus a constant. So it is suggested that we will be using u is equal to a secant theta and du is equal to a secant theta tangent theta d theta. In the given function, u squared is equal to x squared, so u is equal to x. A squared is equal to 9, so we could say that a is equal to 3. Our substitution will involve x is equal to 3 secant theta and dx is equal to 3 secant theta tangent theta d theta. From our problem with the substitution x is equal to 3 secant theta and dx is equal to 3 secant theta tangent theta d theta, if we substitute the corresponding values into the integral, we get the integral of 3 secant theta tangent theta d theta divided by 27 secant cube theta times the square root of 9 secant squared theta minus 9. If we will simplify this using the trigonometric identities, it will be giving us this simplified form, which is 1 over 27 times the integral of cosine squared theta d theta. This could be integrated using trigonometric transformation wherein the exponent of cosine is even. Applying trigonometric transformation, the final answer in terms of our substitution, theta, is equal to 1 over 54 theta plus 1 all over 108 times the sine of 2 theta plus c. Since x is equal to 3 secant theta, we can say that secant theta is equal to x over 3, which is a ratio of the hypotenuse all over the adjacent side. Drawing our reference triangle, the opposite side is the square root of x squared minus 9, and this is solved using the Pythagorean theorem. From our answer in terms of theta, we could use the identity for sine 2 theta, which is equivalent to 2 sine theta cosine theta. From the triangle, we could take the value of sine theta, cosine theta, including the value of the angle theta. So our final answer becomes 1 over 54 times the arc secant of x over 3 plus 1 over 8 times the quantity of the square root of x squared minus 9 over x squared plus c. See you in the next presentation.